So today we will be discussing sound. And again, this is a short chapter because adding sound is something that I think it's fairly easy to do now that you know how to do all the stuff that we have been seeing so far. So adding sound is not uh, very difficult. But it is, I think, a simple way to create richer environments. So sound can easily make a difference in how users perceive the environment. So it's kind of a low effort thing that has a great value. So let's see how we can add sounds um, which in an interactive environment you can think of sound as being something like a background music, but also something like sound events, so things that happen when users do some kind of action. So what we need to do uh, in essence is pretty much follow the two steps that we have been following for adding other types of content like textures or 3D models. So we first need to load the file, the sound file in this case, and we do that through the assets system in A-Frame. And in the audio case, we use this audio tag. So again, audio has a specific element to be used in the assets. We give it an ID, just like all the other kinds of assets, and we also specify the source. So again, um, the source, it does not necessarily have to be, but it usually points to something that we have in our assets folder. So you can, let me see if I can just to make it more concrete. So like textures or not 3D models, because 3D models we store them in a different location in GitHub, but like images, you can drop audio files into this assets folder and then just click and copy the URL just like we do for pictures. And then we just paste the address here in the source attribute of the audio element. So this is the first step. So we load the, the audio file. Um, the second step is to use the audio, so to make it play. And actually, in this second step, we kind of usually do two things simultaneously. So we tell A-Frame, okay, play this audio, and we can tell A-Frame to play this audio when something happens. But we also tell A-Frame where the audio is. So most audio, not all, but most audio we will probably want to position in a given location. You know, like the speakers from where the audio comes from were placed in a very specific location in 3D space. This will allow A-Frame to specialize the audio. So we will hear the same audio differently depending on where we are inside that environment. Now I'll show you that in a minute. Um, Actually, I'll show right now, but again, because I always forget, I'll need to reshare um, with audio from my computer. Okay, let me just again reopen my Windows. Um, but I will share these examples with, and we'll stream the audio. But for most of them, you really must try the examples in your own computer. Because it's only when you have audio headphones you will be able to hear the sound moving through space. And that's kind of important to get the feeling of how audio behaves inside a 3D environment. But so usually we do something like this when we want to position an audio. In some situations, we kind of associate an audio with an existing 3D, um, an existing entity or an existing 3D object inside our environment. So in this case, for example, in this snippet of code, I'm saying that the red box has sound associated. And we tell this by nesting an A sound element inside the box, inside the 3D object. And we can tell the audio to autoplay, so to make sure that the browser starts playing the audio after it is loaded. We can also say that we want the audio to loop so that it doesn't stop when it gets to the end. It will again restart. And the most important thing here for this audio element, sorry, for this A sound element is again the source. So in this case, the source is the source, of course, of the audio file. So we just enter the ID. So hash, this hash symbol and the ID. And when we run this example, I'll open here. I hope you hear the streaming sounds. If you have, I'm not sure if the audio is streamed in stereo. I'm not sure if you hear this effect. So I will approach the box from the left. You should hear the audio on your left here. If Zoom is streaming in stereo, when I approach from the right, you should hear the audio on your left here. If not, then I'm just getting away from the audio so that it doesn't interfere. If not, then you really need to open this example on your own computer and then just move around, and you should hear the sound from a different direction as you move inside the 3D environment. And also you should be able to do this. So you should hear as you approach the object, the box, you should hear the sound louder. And as you move away from the box, you should hear the sound much lower. So sound is specialized in A-frame, and so we have this sense of the distance and the direction the sound is coming from. So I'm going to stop here. And by the way, a warning, all these examples, most of them use the same sound and they can get quite annoying. So you may want to lower the sound level on your computer because that music box kind of gets inside your head. So this is the basic source code that you need. I'm just going to show you the complete here, just to show, but it's essentially the same thing that we had there. So the assets and then a box with a sound inside of it. We kind of already saw this because if we move around the sound, it's kind of the same thing if the sound was moving around us. So we get the sense of the position of the sound. But just to make it clear, we can actually have a sound source that is moving inside the 3D environment. And we already saw how to do this. We have animations. So we can animate an entity that has a sound inside. And so the sound, even if we stay still, we will hear the sound moving around us. So for example, here in this, in the next example, what I have is kind of that technique that I showed earlier, where we have an entity that has a certain position, and in this case, the entity is at the same location as the user actually at the same location as the user's eyes. So it's really on the 0 on the X, 1.6 on the Y. So it's really at the average, at the height of a user in A-frame, and Z also 0. So it's kind of, you can think of like being on the top of our heads. And we also say that this has an animation. So we are rotating this entity that sits right on top of our head. And we're just rotating it to 360 on the Y. So it will basically, it will be spinning like this on the top of our head. And we do this for 15 seconds. And inside the entity, so we have nested a box, and on the Z, we place this box 5 meters in front of this entity. So because this is nested, when we rotate the outer entity, this box will also rotate, but the center of rotation will not be the box, but the outer entity. So it's like we have a box that's 5 meters in front of us, and it starts moving around us. Okay, always at a distance of 5 meters. And then inside that box, we place the sound. And so in this example, you should hear a sound source moving around you. And again, it's the music box. You should hear the sound. When it's in front, you should hear on both. And then as it moves, you should hear on the left and then on the right as it moves around you. So I'm going to stop this. Actually, in the example, the distance is not 5 meters. I think I changed it to 2 meters to make it more obvious. Okay, because 5 meters is a bit far away. It might not be that easy to to notice the sound moving around our heads. But so we can also do this. So this example is just here to demonstrate that you can easily have a sound that is moving around your scene. Another thing, and this is really just kind of some details so that you can fine tune how sounds appear to users. So there are a few other properties that we can control for each sound. So we already saw the autoplay and the loop to make the sound always restart. We can also control the volume. So just imagine this is like the volume control that we have on our headphones or our computer. So if you have a sound file that you think is very high, you can you can set it to a more comfortable level. But then there are um, two other properties that control how the sound level decays, how it lowers with the distance from the sound to the user. And these properties they have kind of odd names. So the first one is roll-off factor. But this is like, you can think of this like the decay factor for the lighting, where some light sources, the light intensity decays over the distance. This is similar. It just has a different name. So this is roll-off factor. It basically defines how quickly the sound will fade away as you move away from it. And for example, here in this next example, we have a roll-off factor of 10. So it will kind of lower very quickly. So if you move away just a few meters, the sound will be very, very low. And there's another property that you can also control, which is called this max distance. Uh, it's kind of a way to make sure that a sound is always heard, even if you are very far away from it. So it kind of allows you to set a distance after which the sound will no longer fade away. So just to make sure, it's a way to make sure that users will always be able to hear that sound. And so we can combine the two. For example, in this example, just notice, and this is something that we kind of already saw in other situations. So in this case, although we have a sound primitive, so we have this element a sound, there are some properties that are not controlled directly from attributes like the first three. These ones, roll-off factor and max distance, they are controlled as properties. So they use this different syntax. They are controlled as properties, so as a value for the sound attribute. Okay, so this may be a bit weird, but this is how things work in A-Frame. So some properties we set them directly as attributes. Others we need to set a generic attribute which has the same name as the component that we are controlling, and then we use that syntax, that property syntax, so name, colon, value, separated by a semicolon. And this, so this next example just shows this. In this case, the sound is different. It's kind of a sonar ping, because I was getting tired of the music box while I was developing these examples. But it's so it demonstrates that if you are very close to the box, you see a very loud sound, but you just need to move a few meters back and it decays very rapidly. So it has, I'm going to show you the source code. So it has a roll-off factor of 10, which is high. I think the default is 1. So it kind of decays 10 times faster, if you will. But I also set a max distance of 20. So even if I get farther away than 20 meters from the box, I will still hear something. It is very low, but I still hear. So it's just a way to make sure that sound doesn't fade away to zero completely. So again, this is kind of fine tuning for the sounds. So it's kind of detail control of the sounds. In most situations, you perhaps don't need to worry about this. Just set the location of the sound. Perhaps just control the volume to make sure that all volumes, the volumes of all the sounds that you have in your scene are kind of uniform, because you don't want that effect that we sometimes get when watching TV and an advertiser appears with a very loud sound that you are not expecting. So you should try to normalize the levels of all the sounds that you have in your scene, and for that the volume is important. And so for most sounds, you just need to make sure of that. Uh, for some specific experiences, you may want to kind of fine-tune things. Another thing which is important is that we can, like animations, this is really similar to animations. So we saw on animations that we could control when the animation started, and we could say, I want this animation to start when the user clicks a box, or when the user moves the mouse or the cursor over the box, or when the user approaches a 3D object. We can say the same things for sound. So in this example here, I'm going to show perhaps first the example. We have two boxes. Each box has a sound inside, and when I click a box, I will trigger a sound. And again, this is the sonar sound. And of course, because I'm in the middle of between the two boxes, when I click the red one, I hear something from my left ear. When I click the green one, I hear the sound coming from the right. So how do we do this? Well, it's really easy. We just need to, on the sound primitive, we just need to add this on attribute. And this will, we are kind of saying, I want this sound to play when the user clicks. The issue here is that for the user to be able to click on something or to look at something, there needs to be some kind of visual element. And so for this to work, we kind of have two approaches, and I'm going to show you both. So one of the ways to allow users to click on the sound, because that's the issue. So a sound is something that doesn't have a visual aspect. So how can a user click on a sound? Well, the way to allow users to click on a sound is to put a 3D object inside the sound. So we kind of invert what we have been doing so far. So on the previous examples, we put the sound inside the 3D object. Like here, for example, the sound is inside the box. But for interaction, we need to think the other way around. So we will put the 3D object inside the sound. In terms of the resulting 3D scene, it's kind of the same thing. Okay, so, but by putting the 3D object inside the sound, we give users a target to click on, because they are clicking on something that is inside the sound, and so the sound will be able to read, to listen to this click event, and allow us to trigger then this on um, parameter. The other alternative is to not use the sound primitive and just put everything inside the 3D object. So this is an alternative. Notice here that we just have a box, and the box has a position, it has a color, and we are also saying that it has a sound. So this is kind of the same, not exactly, but it's kind of the same as saying that the box has a sound inside of it. But in this case, the box is the sound also, you know. So we use the component and say that the box has a sound component, and then we use that syntax to tell everything, to configure the sound. So we say that the source is the ID that we used in the assets, and we say that the on, so the thing that will control the triggering of the sound, is on the click event, and we can also say what volume it has, and we could say if we wanted, we could also apply max distance, a roll-off factor, etc., etc. So these are alternatives that in this example they do exactly the same thing. So I'll show you the source. So we have both. The first approach we use on the red box, and the second approach we use on the green box, and the effect is the same. So we can click on either and hear the sound. In this example, I'm also doing a different thing that I haven't described here in this chapter, but I'm going to tell you. Again, it's a kind of a very specialized thing that you may never need, but I'll just tell you about it so that if you do have this need, then at least you know that you heard something about this, and then you may try to find, or at least ask me again how to do this. So in this example, if you run this, it's easier if you run in your computer and do these actions. If you click, for example, several times on the red box, you hear the first sounds, and then if you click again, nothing happens. So you need to wait for the sound to end, and then you'll be able to click again and hear the sound being triggered. On the green box, I made things a bit different, and you can click several times and you hear the sound being triggered again. Okay, so these are kind of two different behaviors that we can also achieve. So we can tell the sound that the sound will be triggered when the user clicks, but the user needs to wait for the first sound to finish before he can trigger another. Or we can say, and on the green box, that the user can trigger a sound by clicking, and each time the user clicks, a new sound will be triggered. So if we click very quickly, we will hear many sounds simultaneously. So the way to do this is to use another property that I haven't talked about, so just here in this example, which is called pool size. So this essentially is how many sounds can be playing simultaneously. How many of these sounds can be playing simultaneously? And here I just said 10. So this is enough um, uh, for me. So if the user clicks very quickly, you can be hearing up to 10 uh, instances of that same sound. So you can control this with this pool size. And then just to finish, uh, just to show that we can associate events that have nothing to do with the mouse. So we can do the same thing that we did for the animations. If you remember, uh, one of the last examples was an example where we approached the door and the door would open with an animation. We can do the same things with sound. So we can um, approach an object and use that as an event to trigger a sound. And so the way to do this is just use that proximity component, and on the sound just add a proximity sensor first to tell what is the distance that we want the sound to be triggered. So when the user gets closer than 1 meter, I want this proximity sensor to be activated, and the proximity sensor kind of sends out a proximity enter event, and we can say to the sound, well, I want this event to trigger the sound. Or in the second box, so it's just two ways to do the same thing again. In the second approach, we just have a box, so we add all the components to the box. So the proximity sensor is also on the box, and here we just change the on property to be the proximity enter event. And so this allows us to again use that. I'm going to open this in a new tab. The same kind of 3D model of the house with a door that opens, and now we can add the sound. So we can have the door opening, but also hear the door opening. Okay, so we can have everything in the same scene. Um, Here I just added the sound of the door opening. When it closes, it makes no sound, but you get the idea. So you can kind of think of, in a way, you should also think about the soundscape of your scene, not just the visual, uh, not just the landscape, but also the soundscape, how things um, uh, react in auditory also. So in terms of source code, just to show you how we put everything together still in a simple example. So in this case, we need lots of external components. So we have first A-frame, then we have actually something that I'm not using here. I just forgot and I left the script. So I think I should remove this because I don't think this example is using. No. So the environments is actually not needed in this example. We are using the event set and also the proxemic component for the distance. And then we have our assets. So in this case, the assets for the sound. And by the way, I'll tell you in a minute where you can find lots of free sounds. And the assets for the 3D object. So in this case, it's an OBJ. So I load the two files, the OBJ and the MTL one. And then we put the model of the house and also the door. So that approach of using an outer entity and a box inside, so that the door rotates about the hinges, not about the center of the door. And then we position, we scale the door, we add the proximity sensor, we add the animation opening and closing, and we use the start events, the proximity enter and proximity exit. So when the user approaches, we have the animation of the door opening. If the user gets away, we have the animation of the door closing again. And then we also add the sound. So we use the door sound that we loaded in the assets, this one, and we tell that we want to play the sound on the proximity enter, and we want to play with a volume of 1. So in this case, the the volume of the file was okay. So this is actually the default. We could, of course, have another sound with a proximity exit if we wanted, but here I have not added that. And so this is it about sounds. So really simple, just a few properties to configure. Let me just show you where you can find free sounds. Well, of course, if you do a Google search, you'll find lots of websites. But one website that I usually use is actually called Freesound. And here you have, I think you need to register to be able to download. I'm not sure because I always use it after logging in. But here you have a database of free sounds. So a database of sounds that you can just download. And you can just enter a keyword here, and then you need to browse. You usually need to kind of spend some time browsing the database to find you know the perfect sound for your scene. And in some cases you may need to edit the sound. So sometimes sounds have I don't know, they end with some kind of sound effect that you don't want. You just want part of the sound, and for that you need to use a sound editor. Um, but it's a good, it's a very good website. If you need a sound editor, I can also recommend a free one, which is called Audacity, which is a free software that you can download for Windows or Mac OS, or even Linux. And it's really easy, as you see here. So it's a kind of a simple editor. You just open the sound file and then you just select the part that you want. You remove the other parts and then you just export again. So really small software, simple, easy to use. Okay, so this is it for this chapter.